Whoa, almost fell over.
Yes,
Gizmonics.
it's okay.
Backwards.
It's fine.
This is the owner. What's your name?
Gad. Gad.
Gad?
G-A-D.
Gad. Kind of like the Great Gatsby.
Well, almost. More like the original tribe. These original 12 tribes of Israel.
Never heard of him. Gad?
In,
I'll have to read my Bible again. Huh?
Your Old Testament, yeah.
It's been a while since I read that. Well, I'm Vincent Lopresti. How you doing?
Nice to meet you.
I'd like to take
Welcome to Gizmonics.
Yeah, it's a very interesting place. What do you got going around here?
Well, you mean in addition to the elevator?
Yeah. Well, what do y'all do here at Gizmonics? Make gizmos, I guess?
Yeah, but high-tech gizmos, like space hardware, kinematic mounts. It's one of our specialties.
Yeah.
We are in the process of development of a new ultra-high vacuum seals, all metal, unlike the metal ones in the market. They should be, of course, better and improved and whatnot.
Well, why don't you show me your equipment that I kind of noticed the other day. I have no idea what those things are. Maybe you can explain to me.
Start this way.
After you, sir.
We have here a demo device that demonstrates the spherolynder, which is our kinematic mount. If you zoom in here, you can see the unit itself. That's the spherolynder inside there.
And what is that little thing?
It's a spherolynder. It's half a cylinder and half a sphere, all in one piece. And what it does, it enables a kinematic mount like this to carry 100 times the load of the equivalent one with spheres only, with balls, which is the current industry standard. By replacing the balls with spherolinders, you get 100 times the load capacity.
Wow.
And until this came about, there was no good solution for kinematic mount for high loads, whether static or dynamic. So that's our main gadget now.
Got a nice little display. So you take these around to...
yeah, we took this to two places. That's another device that doesn't function at this point. It shows kind of a model of the spherolynder. It's just a piece of aluminum, it's not the real thing, but it shows the half cylinder and the half sphere.
A spherolynder.
Spherolynder. And it sits here in a V groove, and it can move, it can rotate a little bit, just as much as it needs. There's a conical hole in the bottom here, and since there are three of them, when you let down the top plate, it will sit always in the same position. That's the idea of the kinematic mount.
I see.
And these two gauges, when the thing operates, will measure the position of the top plate relative to this block, both up and down and right and left by these gauges. And this will verify. In fact, this device is meant to measure the accuracy of the spherolynder itself. We need the sphere to be highly concentric with the cylinder. And any out of concentricity, if I flip it around, will double itself by showing the horizontal measurement.
Very interesting. So how precise are those meters?
Those meters are 2/10 of a micron.
Wow, that's pretty good.
It is.
Sounds expensive.
There are a few $100s.
I mean the whole test equipment, yeah.
Yeah. The spherolynder itself, in normal manufacturing, what we could achieve until today was concentricity of the sphere on the cylinder to about 30 or 40 microns. We are building a dedicated grinder now to enable us to bring them together to hopefully a fraction of a micron. But we'll be happy with one micron too.
Yeah.
We have two sections of a clean room. This is cleaner. It has more filters on top, so it's cleaner when it runs. This is somewhat less clean, and right now we don't really keep them clean, so you're invited to come in.
So how clean can this clean room get?
This is 10,000. The other one is 100.
Okay.
Which is
particles
per some volume, I think, cubic meter.
So that one's the cleaner room.
The other one is cleaner.
Okay.
The lower the number, the cleaner the room.
Right.
And what you see here is an ultra-high vacuum system. You can see the reading here. It's 1.2 10 to the minus 8 torr. And it shows a normal system all the way up to here. This is a standard system. You can see the number of screws and the size of them that you need for the currently used metal seals. There are 20 screws, 5/16 each. On this end, you could see another flange. Same size, with only 8 screws, 1/4 inch. Way less work. And it seals the same. You see the reading, it's the same vacuum
It saves on
chamber
hardware.
inside. So this is the new seal that we are testing now.
What is that orange thing on the end?
Oh, that's a heating element that we used around here, plus this one.
That's your sensor?
No, it's the heating element.
Oh, heating element.
We tested this seal for temperature cycles up and down to 200 C, which is like 400 Fahrenheit. And it's still
Doing fine.
fighting the threshold, yeah.
How long has that been running?
A couple of weeks now.
Again, looks very expensive.
We didn't build this whole system for this test. We had the system before as part of our normal work, part of our testing equipment. What it's used for mainly is to test outgassing of materials.
Yeah.
Materials that go into sensitive places that you don't want extra molecules coming out of the material. You need to test in here to make sure they don't outgas.
Very interesting. So you sure this isn't a bomb?
I don't know, we'll see.
Looks like a bomb to me.
Yeah, well, it looks like a bomb in the movies.
Yeah.
This is what our idea of bombs are.
Yeah.